Hello and welcome to the Bearded Math Man's YouTube channel. Hey, in this episode what we're going to be talking about is what algebra is and how that helps us to solve equations. We're going to start off with simple stuff like this, but you should be well equipped to get to something like that. Now let's get right into it. But before we do, hey, as you're watching the video, if you think this video might be helpful for somebody else, give it a like. It'll help them find it. And if you think this video is something that is helping you and you would like to be notified when new stuff is being released, go ahead and subscribe. I mean, what's to lose? It's free, right? All right, let's get into it, shall we? Now, could you write a story without knowing how to write a sentence? That's weird. Of course, you could tell a story, right? But how is it possible you could write a story if you don't know how to write a sentence? Because after all, sentences are what make up paragraphs. Paragraphs make up the story. Man, you have to know the rules of the language. So you got to know the punctuation, the grammar, the spelling, all of these conventions. Otherwise, you can't write. Now, math is a language. We're going to see how all this ties in here in just a minute. What algebra is algebra is finding resolution through regression. Now, resolution, you see the word right there, solution. In resolution, we are going to find a solution. Regression means that we're going to apply the rules of the language of math backwards in order to come up with a solution. You see, math is a language, and it has rules like punctuation, spelling, and all of these other conventions, right? And because math is a language that can be written, just like you can read this sentence right here and understand what it is, because I know the rules of English and you know the rules of English, we're allowed to communicate even though I didn't read this to you. And so what we're going to do is we're going to use the rules of mathematics, the linguistic rules or PEMDAS. We're going to use those to come up with solutions for something like this. Now, in math, this is 9x plus 4 equals 11. What it really is happening right here is we have 9 times some number plus 4, and that is exactly the same as 11. This over here is the same exact value as 11. And when you're doing regular math, right, most arithmetic, you're just using the order of operations. You do anything in a group, exponents, multiplication, division, left to right, addition, subtraction, left to right. So you would multiply, and then you would add. The reason you can't take this any further is because you don't know what x is. And since you don't know what x is, you can't multiply it with 9. And since you can't multiply it with 9, you can't add 4 to it. So that's as simple as you can make that. Now, when we use algebra, we're going to flip that order of operations on its head. We're going to add and subtract first. We're going to do the inverse of those. And we're going to do the inverse of division, multiplication. Then we're going to have to figure out how to handle tricky, ugly exponents and square roots and cube roots and all that stuff. And then perhaps the trickiest thing of all is there's lots of ways to group things. We're just going to see one or two ways we can handle groups today. We're going to spend a lot of time on that in the future, right? So anyway, when we're doing inverse operations, we are going to add and subtract first, do the opposite of that, and then we're going to do the opposite of multiplication and division next, right? So here's our order of operations. Let's take a look at it. Make sure we're crystal clear on what's happening right here. So multiplication is repeated addition. If you had 3 and you added it to itself 5 times, that's the same as 3 times 5. This 5 tells you how many of this number are being repeatedly added. So that's what the 5 says. So multiplication is kind of a shortcut for addition. It's a way to take a long addition expression and make it smaller. But it only works if it's repeated. Here, we're adding different numbers together, so there's not a notation that we can use to make this smaller other than to say that it's equal to 20, to find its sum. Now, exponents, very similar to multiplication. This exponent right here tells us how many of this number are multiplying with each other, right? And so this is like compressing repeated multiplication. Multiplication's compressing repeated addition. So these are making big giant numbers really, really small. And so if we want to change the way we do the order of operation, then we have to do that with a group. So we could intentionally put these in parentheses, and then you would have to add first, and then you could multiply. So this also says we have 5 groups of 2 plus 3, all adding together 5 times in a row, right? And so here you have to multiply, or you have to add first, and then you would go ahead and multiply. So let's go ahead and talk about inverse operations. Now you know that when you're doing addition you do it in subtraction, you do left or right, whichever you see first, but they're inverse of each other because 5 and negative 5 are opposites. So 5 minus 5 is 0. And you don't need to write plus 0. You don't need to write minus 0. So when you're doing equations and you're using algebra to solve them, what you're trying to do when you have addition or subtraction is you're trying to turn that number into a 0. Now, multiplication and division, those are inverse as well. 5 and negative 5 times 5 and divide by 5, times 5 and divide by 5, they're exactly the opposite of one another. And when you combine those together, you get 1. So the idea when you're using inverse operations is that if you have multiplication or division, you're trying to do an operation to turn that number into a 1. If you add 0 and you multiply by 1, nothing's changed. You have exactly what you started with. Now here's where it gets a little tricky. Exponents and square roots, you might not remember, but they're actually the same. So let's go ahead and talk about the exponent of 5. The opposite of the exponent of 5 is an exponent of 1/5 or the 5th root. And here's why. If you had 3 to the power of 5 and you raise that to the power of 1/5, you have to multiply those. 5 times 1/5 is 1. 3 to the power of 1, you don't even need that 1 right there. Now, same thing here, the 5th power of 3 to the 5th. Well, that's saying what times itself 5 times is equal to the radicand. Well, here we go. We have a number multiplying by itself 5 times, so 3. So the idea is that when you have exponents, you're trying to manipulate them to get an exponent of 1. Now, we'll get into the stuff with the groups a little bit today, but a lot more in the future, right? So you can't do math if you don't know how to write. If you don't know the rules, you're going to have a lot of trouble, especially when we're going to start doing algebra. You really have to understand that order of operations. It is well worth the time we've spent. So we're going to use the inverse operations, and then we're going to be solving by doing those operations backwards, right? All right, now, one last thing before we get into actually doing some examples. And I know that you're probably ready to start doing some math, but we're getting these ideas solid so that when we start doing math, and I start referring to what's really happening, you have a good understanding. That understanding you're going to keep and you're going to remember. So, golden rule, right? In math, the golden rule is what you do to one side, you have to do to the other. But why is that? You've been hearing it forever, right? So like, for example, 9x plus 4 is equal to 11. That means that it's exactly the same as, and in math, everything is taken to be literally true. Nothing is going to be false. So when we see an equal sign, that means that this side is the same as that side. Equal means it's exactly the same size. So something like this is true. 5 times 3 plus 2, the quantity 3 plus 2, that's 25. This is true. And so if I were going to do something to the left side and the exact same thing to the right, like add 8 and add 8, then it's still equal because this is 25 and this is 25. So if I add 8 to 25 and I add 8 to 25, it's still exactly the same. Now if I divide that by 19, I have to do the same thing to the other side. I have to divide that by 19, still equal, right? Okay, so this was equal. What you do to one side, you have to do to the other. Now, here's what we're going to be talking about today, right? You see, I think you know that the answer for x here is going to be 2, right? But we're going to be talking about how we go about doing that. We're going to talk about how we use algebra to find the answer by doing the order of operations backwards. Before we get into that one, though, let's do a simpler problem. Now, you might be able to figure this one out in your head, but it's a fraction. So let's go ahead and take a look at inverse operations, SADMAP, right? Now, we've got to solve for x, so that means we have to get rid of the 2, and we have to get rid of the 7. So the 2 is subtracting, the opposite of subtraction is addition, and the 7 is multiplying. The opposite of multiplying by 7 is to divide by 7. So we're going to do them in this order, right? We're going to do the opposite of subtraction, then the opposite of addition, and the opposite of division, multiplication. Then we take care of exponents, and then we do anything in a group last. So we're going to add 2 to both sides. These make 0. You don't actually need to write 0, you see, and usually you want it. And then we're going to go ahead and divide both sides by 7. Now here's something that's kind of weird. 0 divided by 7 is 0, but we actually do have to divide everything on both sides of the equal sign, all terms. We have to divide by 7. So these 7's reduce and make 1, and you're left with x equals 17/7. No problem, right? So let's go ahead and take a look at the one we were doing a bit just a few minutes ago. This one's a little more complicated because x is stuck in a group right here. And even though this is adding, the 3 is adding, addition comes before multiplication, the 5 is multiplying, it's stuck in a group. So this addition is going to go last because it's in a group. But let's make sure we're rock solid on some vocabulary here, shall we? To solve means that you're finding the value for x, or whatever letter you're solving for, that would make the statement true. And you're done solving when you have the x by itself and everything simplified. So like x equals a number, you're done, right? So we're going to go ahead and solve right now for x. We're going to get x by itself, and we're going to get everything else on the other side. So keeping the x from being by itself, we have a 3, we have a 5, and we have a group. So let's go ahead and set all that up over here with the order of operations, right? We're going to have to take care of that 5 first because it's not in the group. It's multiplying, and the opposite of multiplication is division. Then we're going to take care of the 3 after that. So we're going to divide both sides by 5, then we're going to subtract by 3. We're going to do it in that order, right? So divide by 5, those 5's reduce, subtract 3, 5 minus 3 is 2, boom, done, just like you knew, right? Now, how do you know if you're right? You're right if you can take this value and you can plug it in and you can do the math and you get a true statement. So you get this side is equal to the right side. The left side of the equal sign will be equal to the right side, and that's exactly how you know if you're right. So let's go ahead and do that. 5 times, 3 plus 2, of course that's 25. This is what we've been talking about the whole time. But that's how you know if you're right. Okay, now, here are our big ideas so far, right? The rules of math, or the order of operations. PEMDAS, however you say them, wherever you live, it's the order of operations, and they're the same. The acronyms might be a little different, but it's the same exact idea, right? The acronyms just help us remember. Now, algebra, what we do is we reverse those rules in order to find solutions. And so the idea is we want to do the opposite of add or subtract in order to be adding or subtracting a 0, because plus 0 doesn't change anything. If we're going to do the opposite of multiplication or division, we're trying to get a 1. Times 1, divide by 1, doesn't change anything. We need to manipulate exponents, though, so we get an exponent of 1. That's where it gets a little bit of trick. That's where it gets tricky. We're going to have to spend a little time on that. Probably not going to be in this video. It's going to be in future videos, but we'll get there. Now, when you're solving, what you need to do is you're going to need to get x on one side of the equal sign. It doesn't matter which. And you need to get all of the other numbers on the other side, get them all combined, simplified, and pretty. And when you have x equals just a number, and it's all the way simplified, you're done, right? Now, you're right. If you can take that number, that value for x, you can plug it in, and you get a true statement. So here, I want you to try this one right here. It's a pretty simple one, and I bet you might be able to figure it out in your head. Just using the facts of arithmetic, 5 times what plus 4 is negative 6. You might be able to figure that out in your head, but I want you to try, even if you can get it in your head, I want you to try using your inverse operations, because you need to have all of the tools you can, and if you can take a simple problem like this and you can develop that process, then that can be applied when it's a little bit trickier. So go ahead and pause the video, and when you're done, unpause it, see how we do. Did you do it? No, come on, don't be lazy. Get off the couch, go get a pencil, get a paper, give it a shot. I'm sure you did. Sorry for nagging. Anyway, here we go. Here's the problem. 5x plus 4 equals negative 6. So let's go ahead and set up our inverse operations. You don't have to do this every time, but if you're struggling, this really helps structure all of your thinking. And even though this might be easy for you, if you set up SADMAP and you plug all the things in where they belong, that's going to help you whenever it's not so easy. All right, so we have to get rid of a 4. We have to get rid of the 5. The 4 is adding, so we're going to subtract it. The 5 is multiplying. We're going to divide it, and we're going to do it in that order. So we're going to subtract 4 first. That gives us 5x plus 0 equals negative 10. And then we're going to divide both sides by 5. Well, that makes 1. That makes 0. We don't need to write plus 0. We don't need to write times 1, and that equals negative 2. So again, when we're getting rid of division or multiplication, we want a 1. When we're getting rid of addition or subtraction, we want a 0, just like this. So x equals negative 2. Done and done. Now, a quick word. Here, this is kind of interesting because in algebra, in math at this level, we write math across, just like we do in English. But then all of a sudden, we write math in a column, like this right here, and we're adding these vertically. And that's a little confusing because this is like elementary school style, doing math in a column. And another way you could see it is if you didn't write it in a column, you wrote it all vertically, you would need some extra space right here to write the -4, or you'd have to write it in the front and then combine like terms. And so over here, it shows you another way of writing the same thing. Anyway, let's try another one, right? Do you see the relationship between the problem we just did and this problem? Do you see how they're almost the same? Why don't you go ahead and give this one a try? Pause the video, give it a shot. All right, I'm going to go ahead and set up SADMAP. Now, here's one of the things that's tricky about this problem. The x is stuck in a group. There's not any parentheses, but when you have a fraction like this, the numerator is grouped together. So is the denominator. The denominator only has one term, so it's not a huge deal, but this is definitely grouped together. And so the very first thing we have to do is we have to take care of what's making that in a group, and that's the dividing by 3. And so what I'm going to do is I'm actually going to write the dividing by 3 on the left side, and then we're going to take care of the group. So we're going to multiply both sides by 3, and then I can take care of everything else. So I'm going to multiply both sides by 3, and what's going to end up happening is I'm not going to distribute and get 15x plus 12, because this is 3 over 1, and we're dividing by 3, and that can be reduced. This side's going to be negative 18. But let's talk about the reducing real quickly, right? Here's what's happening. You would never write this out, but 3 over 1, this is not what we usually write. We usually write this just 3 times, but it's really 3 over 1. And there's the commutative property of multiplication, which means you can change the order. 1 times 3 is the same as 3 times 1. And so if you switch them, what you end up with is instead of 3 over 1, you have 3 over 3 now. And 3 over 3 is 1. You don't need to write times 1. That's why we're done with that. Okay, now from here on out, pretty easy. You're going to subtract 4, and then you're going to divide by 5. And I think by this point, you totally got it. But just to make sure, you cannot start off by subtracting because this is in a group. The group goes first, then the addition, subtraction, and then the inverse of the multiplication and the division. So you're going to get x equals 22 over 5. Good to go? Now, we're going to take it one step further. Oh boy. Do you see how this one is related to the one we just did? Do you see? We have a group, but then we also have something at the end right here. So this is one number. This whole thing, this whole fraction is one number plus another number right here equals something else. So we have a number plus 1 equals negative 6, right? So this really has to equal negative 7, the whole thing, but we'll get to that in a minute. Here's the issue. Just like before, x is stuck in a group. We have to get it out. The problem is, what are we going to do first? Are we going to multiply everything by 3? Or are we going to subtract 1? It doesn't matter. You'll get the same answer. Either way you do it. Why don't you go ahead and give it a shot, though? Go ahead and pause the video. Try it again. When you're done, just click play, right? All right, we're going to go hit started. I'm going to go ahead and show you both ways of solving this. What we're going to do first on the right is we're going to go ahead and multiply by 3. Here's the thing, though. You have to multiply everything on both sides of the equal sign by 3. On the left, there are 2 terms. We have this is one term, and this is another. We have to multiply both of them by 3. We have to distribute that 3. Over here, it's pretty easy on the right, right? However, if you're going to subtract first, you subtract 1 from both sides. That's maybe a little simpler this time. So here, we're going to go ahead and distribute. The 3's here reduce, just like they did on the last example, and 3 times 1 is 3. Of course, 6 times 3 is 18. Negative times positive, negative, right? So go ahead and combine those terms right there. 4 and 3 make 7, no problem. Now over here, all right, we have a little bit of a different situation. Looks different, looks strange, but when we apply our inverse operations, we're going to be rock solid. We're going to multiply this one by 3. We're going to subtract 7 over here. No problems. So when we multiply this by 3, the 3 is reduced. We get negative 21. And from there, you're just going to use your inverse operations. You're going to subtract 7 over here. You're going to subtract 4 over there. Either way, you get x equals negative 5. And we're done. So the reason that it's tricky, though, is sometimes you're not really sure which way is going to be best, and you're afraid if you try one, you might get stuck that way. But you can't think like that. You just got to drive through. Just dive in, give it a shot. If you get stuck, you can try it the other way. All right, so here are our big ideas. We already talked about all these. How comfortable do you feel with all of this? When we're using algebra, we're doing inverse operations. We're undoing the order of operations. We're doing the inverse of the operation itself. So if we have division, we multiply. And we do everything backwards according to PEMDAS. We do SADMAP, right? When we're adding, subtracting, we're trying to get a 0. When we're trying to get rid of multiplication or division, we want a 1. Same for an exponent. We didn't really talk about too many of those because that's a little more complicated than what we really are going to get into in this lesson. But we'll do that soon, okay? Now, what we're trying to do, we're trying to get x on one side of the equal sign, all the other values on the other side, right? When we have x equals just a number, there's not another x, we're done solving for x. And we're right if we can take that value and plug it in. Okay, so in the description below, I'll leave a link so you can download this homework assignment. And you can see a whole bunch of other practice. You can see some notes that are written up that would help you with this lesson. And you can go to my website. I'll put a link there. It's thebeardedmathman.com. I am at the very moment redesigning the whole thing. It looks like this right now. You go to courses, you click on courses, and you've got, well, we're going to go to Algebra 1 right here. In Algebra 1, right now, everything in the number unit is done. A bunch of stuff in the foundations of algebra, that's what we're talking about right now, is done. And there's going to be the entire year's worth of material broken down into 6 units. Each unit is completely fleshed out. There are notes for every single day of the entire year. There are homework problems, there are videos, there are PowerPoints, all kinds of stuff there to help you out. So if you're trying to learn on your own, you're sick, you're a teacher, you want to get some good materials, you're just a student trying to get caught up or study, it's all right there. It's all free to use. So what we're working on right now is inverse operations. And we're going to go to inverse operations, and we're on part 1. All the notes are there. There's going to be an assignment. There's going to be a lesson. It's all there for you to download and use. So anyway, give it a shot. Take a look. Once again, I do thank you for watching, and I hope this has been helpful. There's a lot of information in this video. Solving equations is a very complicated thing, and it's something you've got to apply in very complicated ways in the future. So you have to be proficient. You have to be able to do it quickly, but you also have to understand. So if you've been working hard to understand, you're going to be really good to go. So once again, give it a like, share it, help other people find it, and if you want to be notified when new stuff's coming out, just go ahead and click subscribe. Anyway, thank you very much, and I hope you have a wonderful day.